Strange but true, three molecules with sp3 centers show different bond angles, and they shrink as we go from N to O to S. Why? The answer lives in electron domains and lone pair effects. In this video, you'll learn how to assign hybridization to common heteroatoms, N, O, P, and S. By counting electron domains, how that predicts bond angles when trends break down, and how to work through 4 real examples. The core rule is simple. Count electron domains around the atom. Sigma bonds plus lone pairs. 2 domains equals sp, 3 equals sp2, 4 equals sp3. Pi bonds don't add domains. A double bond still counts as 1. In methylamine, nitrogen has 4 domains, 3 bonds, and 1 lone pair, so sp3 hybridization. Lone pairs repel a bit more than bonding pairs, so HNH is slightly less than 109.5 degrees, or about 107 degrees, while the adjacent CNH angles open a touch. In methanol, oxygen is sp3 hybridized, or 2 bonds plus 2 lone pairs. Lone pairs contract angles. HOC is near 108 to 109 degrees, while HOH in water is about 104.5 degrees. Same hybridization, different crowding around the center changes the angle. However, avoid 2 traps. Don't count a double bond as 2 domains, and don't start from charge. Always count sigma bonds and lone pairs at the atom you're analyzing. So far, we've covered domain counting to hybridization. Lone pairs compress angles, and a double bond counts as 1 domain for geometry. Want to turn those milestones into mastery? Tap the link to access the practice test, flashcards, and study guide, then jump right back into the video. Lock in what you learned and keep going. For phosphorus in methyl phosphate, count 4 domains or 3 singles and 1 double to sp3, roughly tetrahedral or approximately 109.5 degrees. On the other hand, third-row elements can be hypervalent in some structures. For assigning hybridization, domain counting works reliably here. Nitrogen isn't always sp3 hybridized. In an imine, it's sp2 or 3 domains, and in a nitrile, it's sp or 2 domains. Same rule, new context. Sulfur in dimethyl sulfide is also sp3 or 2 bonds plus 2 lone pairs, but CSC is around 99 degrees, noticeably smaller than the ideal 109.5 degrees. As we move down a group, valence shells get more diffuse, and VSEPR angle predictions become less reliable. So, compare to measured values when possible. Let's systematize it. 1. Sketch or inspect a Lewis structure. 2. Count sigma bonds plus lone pairs on the atom. 3. Assign SP, SP2, or SP3. 4. Predict angles, then adjust for lone pairs. And recognize that third row and heavier elements can deviate from neat VSEPR angles. To recap, count domains to assign SP, SP2, or SP3. Lone pairs shrink angles. NO often sp3 in amines or alcohols. P in methyl phosphate is sp3 or approximately 109.5 degrees. S in dimethyl sulfide is sp3, but shows a smaller angle or about 99 degrees. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.